Okay, so we know what logarithmic functions are. How do we graph them though? And how do we graph them without doing that inverse method that we talked about before? So our essential question today, how do I graph logarithms? Okay. Reminder, the translation. Don't forget that this is what a logarithm is. If you see something that's log base b of n, what that means is, hey, what power of the base gives me the number, okay? So if you see something that looks like this, you can translate it into this. And the reason is because I'm looking to see what power of the base gives me the number. That's what the translation is saying. So let's take that knowledge and use it to graph our first, and this is like a parent function, right? Remember, the way you say this is log base 3 of x. Log base 3 of x. If you learn how to say it well, that'll help you miss some mistakes that some people make for how to write this thing. It's not like this. It's log base 3 of x. It's not log 3 to the x. Okay, anyway, I'm rambling on. You just want to see me make a table of values. So we need to be smart about values that we can plug in. First of all, something that you should know is that the function's going to look something like this, and there will be a vertical asymptote through x equals 0. And if you think back to what we did on Friday, you can kind of remember why it is. It's because we're kind of flipping over that exponential function. So because of that, notice that the function does not live anywhere over here. In other words, if I plug in negative values for x, y is going to be error. Like it doesn't exist. It does not make sense to plug negative values in for the logarithm. And again, we can see that graphically with over here. We can also think about what it would mean to take the logarithm of a negative number. So let's try taking it of negative 9. Remember, what this means is what power of 3 gives me negative 9. But there's no way for me to get a power that gives me a negative number. If I do 3 squared, that's positive 9. If I do 3 to the negative 2, that's 1 over 9. But there's no way for me to get this negative 9. So because of all those reasons, because of the graph, because of what the logarithm really means, I cannot plug in any negative values. So let's think about what some values are that I can plug in. First of all, I can plug in 1, right? Because let's think about this. Log base 3 of 1. What power of 3 gives me 1? Well, that's 0. Remember, what I'm doing is 3 to the x equals 1. What power of 3 gives me 1? Well, it's 0. The next nice x that I could plug in would be 3, right? What power of 3 gives me 3? That would be 1. And I think the next nice one would be 9. I'm getting ahead of myself. What power of 3 gives me 9? Well, 3 squared gives me 9. So this would be 2. I could also do some fractional values just to get a good shape. If I do 1/3, what power of 3 gives me 1/3? That would be negative 1. If I do 1/9, what power of 3 gives me 1 over 9? That'd be negative 2. Notice that these are kind of flipping what the exponential function would be, and maybe you remember that, maybe you don't. Anyway, let's graph these points. Over 1/9 down 2, over 1/3 down 1, over 1 up 0, over 3 up 1, over 9 up 2, and sure enough, here's the characteristic shape that looks like an exponent but sideways. Make sure you're seeing that it does approach the graph, the asymptote. It gets very, very close to it but never touches it. Let's label a couple things. First of all, the asymptote is x equals 0 because, again, I am never actually getting to 0, and also I cannot cross it and get into the negative values. Let's talk about domain. Like we said, I can't do negative values. I also can't plug in zeros. Our domain is x greater than 0. How about our range? I can go up and down as much as I want, so our range is all real numbers. And let's finally do end behavior. For our end behavior, as x is going to the right, as x is approaching infinity, y is also going up, approaching infinity. As x is going to the left, remember I want to do as x approaches 0 because I'm not going all the way to negative infinity. I'm only going to 0. So as x approaches 0, y is going down. Okay, let's just do one more example. We'll transform some things. First of all, we need the parent function table. So let's do the parent function y equals log base 2 of x. Okay, so this is our parent function. And what are some nice x's? 1 is nice. Log base 2 of 1 is 0. 2 is nice. Log base 2 of 2 is 1. 4 is nice. Log base 2 of 4. What power of 2 gives me 4? That'd be 2. I could also do 1/2, that's -1. I could do 1/4, that's -2. And if you notice, this kind of lines up with what we were doing back here. I'll let you figure out the pattern, but here we're kind of doing powers of 3. Here we're kind of doing powers of 2. So anyway, here's my parent function. Over 1/4 down 2, over 1/2 down 1, over 1 up 0, over 2 up 1, over 4 up 2, and our graph, again, looks like this with our horizontal asymptote through x equals 0. But this isn't just any old function. This is a transformed function or an advanced function. So we need to take care of this reflection and stretch. This is a reflection. It is also a stretch. And both those things are happening by -2. Remember, we're multiplying the y-coordinate. So here, where the y-coordinate's 2, it's going to become 4. Sorry, -2 times -2 is 4. -1 times -2 is 2. This would still be at 0. This is 1, it would go to -2. This is 2, it would go to -4. Remember, I'm multiplying all of my y values by 2. -2 in this case. Okay, so there's the stretched function, but then I need to take care of, with a spicy new color, what looks spicy? Green looks spicy. Okay, so I'm shifting left 3, and I'm shifting down 4. So each one of these points, each one of these blue points, left 1, 2, 3, down 1, 2, 3, 4. You have totally done this before, so I will go through it as quickly as I can. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And 1, 2, 3, 1, 2, 3, 4. Okay, easy. We just need to make sure that we know where the asymptote is. Normally the asymptote is at x equals 0. But since we're shifting left by 3, now the asymptote will be at -3. So here it is, and we can see that does kind of line up with our points. So here is our reflected and translated function. The green one is the final answer. Let's just talk about domain and range and stuff. First of all, we have an asymptote. It is at, as we said, because of the shift left, we have an asymptote at x equals -3, the vertical line through -3. We have a domain. X has to be greater than that -3. Our range, as always with logarithmic functions, is all real numbers because I can go up and down as much as I want. Finally, let's do end behavior, or end be, as I'll abbreviate it. Okay, as x is going to the right, looks like y is going down, so y is going to -infinity. As x is going to the left, really it's approaching this -3 asymptote, and y is going off to +infinity. Oh, what a whirlwind of fun, adventurous times. Whoa. I have no idea what happened, but it is very confusing, and it is not letting me go to the next slide, which is the summary. Was that I literally just plugged in my keyboard and pressed buttons until it went back to normal, so not sure what happened there. Anyway, the summary, translations, they're exactly the same. Look, all these translations, they are exactly the same as we've done a million bazillion times. You should be great at these by now. Just know that the parent function has that vertical asymptote, and it has some weird end behavior, that x going to -3 rather than x going to -infinity. But I think for the most part, as long as you can make the appropriate xy table, and as long as you remember what logarithms mean, you'll be fine. Thanks for watching.